Hello everyone, welcome back to the channel. So previously we have created videos for how to create a build system like linker file, startup file, and how to create ELF file, how to create a CMake file, all those videos. So this will be common for all projects. So if you are working for any projects, you have to understand all these concepts. In this video, we are going to discuss about LED blinking in STM32F446RE controller. Okay, here the first step is we have to enable a clock for our GPIO pins. So what I will do, I will paste this. So this is the start address of the clock control. RCC means reset clock control. So the start address is 0x4002 3800. So I'm assigning it into some macro which is called RCC base. So this is the start address. Then GPIO A base address, that is 400240. This is the GPIO A base address. So now we have a base address of clock and GPIO A. Now I will paste this code and we will see step by step. The first step, from RCC base address, we have to search for the 30th address. So RCC base address is 0x40023800. From here, we have to search for the 30th address. That is offset in left side you can see 0x30 here. In this name, we have created a macro, and here GPIO A enable in the 0th address. So we are pointing to RCC AHB1 ENR using this macro. Using this macro, we can enable a clock for GPIOs. Then second step is mode register for GPIO A. Now we have to configure that particular address. So as of now, we know the GPIO A base address. From there, uh, where GPIO mode register is there. So first we'll go and see GPIO base address. Then we can see here GPIO A mode register, which is offset 0. Using this, we can control GPIO functions. So here there are different modes are there: input, output, alternate function, and analog mode. Using this register, we can change the mode of output pins. And you can see the offset address is 0. So from GPIO base, 0th address is mode register. That is the meaning of this macro. Okay, next step, GPIO output data register. Using this, we can control the output pins. Now we are going to control PA5 pin, which is a fifth bit, and the address offset is 14. So we are going to use base address plus 14 to access ODR register. That is the meaning of these registers. Okay. Now we have to write a code in while loop. So the first step is we have to enable a clock for GPIO A. Now I have pasted this using this macro, and I can go to reference manual so that we can see which address is for GPIO enable. So I will search directly through page number. Okay. Now we are going to reach a RCC address, and I will go to AH B1 ENR register. So the 0th bit is GPIO A enable. So using this bit operations, I'm setting the 0th bit using R operation. So it will enable a GPIO A clock. Okay. The second step, we have to clear the mode registers. We have to clear the existing configuration using this bit operation. So to control PA5, first we have to clear bit 10 and 11. So using those bit operation, we are going to clear bit 10 and 11 for PA5 output pin. Okay, this is the meaning of this configuration. Okay, the next step is we have to enable the output for PA5. So I will use this step, GPIO mode register, and I will use R operation, and I will set a 10th bit to enable the output function for PA5. So here you can see 01 is the general purpose output mode. So I have to set a 10th bit. Okay. After doing all these configurations, these are the mode selection configurations. Then I will paste the remaining part of the code. Yeah, I will use a while loop and I will use a GPIO ODR bit. I will use a XOR operation. So what it will do, I will go to the register first. In ODR, fifth bit, meaning which is a PA5 control bit. So I will come back to code. I will use XOR operation and I will use the left shift operation and I will set that bit. So every time it will read the ODR 5 bit and it will toggle it. Okay. If you have doubt, please do comment. I will explain more in detail how bit operations are working. Okay. Then I will use a delay function. Also, I will paste a delay function. Since it is to create some delay, I'm using for loop. It will run for some time so that we can see a delay operation during code running. So every time it will call delay function and change the bit. Again it will call delay. Again it will change the bit. This is the operation of this LED blinking program. Okay. Now I will open terminal and I will start build my code. Okay. Let's wait. Yeah. Now I will use make clean first. First I will clean all my builds, existing builds. Then I will clear the terminal and I will use make build to compile my code. Okay, now it created a ELF file in my build folder. So since I have already created my environment, so please watch previous videos. Okay, now I have connected my STM32 controller here. Now I will use the command called make flash. This is the command I am using to flash a binary file into the controller. Okay, now I will execute this command. It will start flashing my binaries into my hardware. Now you can see my LED is blinking, which is an internal PA5 LED light. So this is how you can program a LED blinking program for STM32. Thanks for watching the video and do subscribe for more videos.